welcome back, and I'm actually continuing the video series on organic chemistry over here. To be quite honest, it's been 2 years since we made the last videos, and we are continuing today. But nevertheless, so we have the hydrocarbons and we are looking at the alkynes. In the alkynes, it says there is at least one triple bond. Okay, so this we generally mean that whenever we have one alkyne, a type of hydrocarbon, that there is at least one triple bond that makes it an alkyne, right? Between two of the carbon atoms. We say they are unsaturated compounds and they are therefore highly reactive. And many of the alkynes are used to synthesize other chemical products, and we'll talk about that another time. Okay, so if you remember from the previous video, we dealt with what this is over here. We say that this is the general molecular formula of something that has at least one triple bond. The molecular formula, if there's more than one triple bond, it will be a little bit different, right? But these general formulae apply if we have one of the functional groups applied to that molecule. Okay, so here's an example. If I were to take C4, it's going to be H2 multiplied by 4, which is 8. 8 minus 2 gives me 6. And we can actually draw out that hydrocarbon, in this case being an alkyne, with 4 carbons where there's at least one triple bond. And you can decide where you want to put the triple bond. We'll look at that next. Okay, I think I also need to speak a little bit slower. Again, I tend to rush myself. So we can see over here, here's one carbon, and here's another carbon, and between the carbons, there is one triple bond. There's bond 1, bond 2, bond 3, that's a triple bond. Around every single carbon, we know we need at most 4 bonds, right? So I've got 1, 2, 3, 4 around that carbon, and I have 1, 2, 3, and 4 around that carbon. Okay, so that's the alkynes. It is a subgroup of the hydrocarbons, meaning it contains only hydrogen and also only carbon. And we've dealt with the alkanes, which has all single bonds, the alkenes, which has at least one double bond, and now we are introduced to the alkynes that has at least one triple bond in the molecule makeup. So I'm going to work on this example, C4H6, on the next page, right? And we've got a white screen over there, and let's see what C4H6 looks like. Okay, and that's according to the general formula that we've looked at, C4H6, and this is going to be something along the lines of CnH2n minus 2, and remember that is the general formula for the alkyne hydrocarbons. Okay, so let's do this. We've got this, right? We need to have 4 carbons. 1, 2, 3, 4. Now I want you to tell me, where exactly do you want to place the triple bond? Do you want to put it in the middle? Do you want to put it on the first carbon? Okay, let's go with your decision. First carbon it is, right? So if it's on the first carbon, remember every single carbon can only have at most 4 bonds. So you have 3 already on this carbon, you can add 1, and there we go. So now you have 4. On this one, I can only have 4. So I've got 3 on this side, I need to add 1 on that side, and that carbon is done. Around this carbon, I need 4 bonds. So I can place 1 over there, 1 over there, 1 over there, and now I have 4 here. I place that one there, I have 2 around this one, 3, and there I have 4. And so now I just fill in the hydrogens, and I want you to draw it out. Remember, you need to engrave the neural pattern. Draw it with me. Okay, and a hydrogen over there. And now let's do this together. Let's see, did our general formula work, right? How many carbons do I have? I have 1 carbon, 2 carbons, 3 carbons, 4 carbons, in which I number closest to the functional group, and in this case, the functional group is going to be this triple bond, right? So I'm just going to put that over there. The F group, which is the functional group, right, is the triple bond. Okay, and the homologous series to which this belongs, we've studied this. The homologous series is the name of the group that contains the same functional group, and that is going to be called the alkynes. Righto. Okay, 1, 2, 3, 4. Okay. And now let us name it. Let's see how the naming works. Do you remember your organic chemistry naming summary sheet? Let's just go to it very quickly. Let's just bring up our summary sheet and let's see. As you can see on the summary sheet, 4 carbons starts with bute, and let's just get that back over there. Bute is going to be, sorry, my bad. C4H6, CnH2n minus 2, and you've got 4 carbons, so you know that the name has to start with BUT, bute, and you also can see that there is a triple bond in it, so it's going to be butyne, and we need to indicate where that triple bond lies. Does it lie on the first carbon, the second carbon, the third carbon, or the fourth carbon? In this case, it lies on the first carbon, so we say but-1-ine, but1-ine, and that's going to be the name of that hydrocarbon. Okay, so there we have our first example. I want to choose another example very quickly, and you just give me a number. C7, very good. That's going to be H. Remember, if this is the general formula, it's CnH2n minus 2, and this is going to be a 7. 2n minus 2 gives me the following. 2 times 7 is 14. 14 minus 2 gives me 12. And you can start seeing this pattern. Just see, double 7 is 14. 14 minus 2 gives me 12. Oh, that's the relationship. That's actually double minus 2, so this has to be an alkyne. And then we can actually go and we can break it down and we can say, okay, 1, 2, 3, 4, 5, 6, 7. Very good. And unfortunately, the molecular formula over here only tells me the number of carbons in the molecule and the number of hydrogen atoms in the molecule. What it doesn't say is where the triple bond lies. According to this general formula and this molecular formula, I know that this is an alkyne, but I don't know where the triple bond is. So let's randomly choose a triple bond over there. There we go, right? There's a triple bond. Now we can start here. This needs 4 carbons. So 4 bonds around the carbon atom. So 1, 2, 3, 4. This also requires 4 bonds around the carbon atom. 1, 2, 3, 4. This requires 4 bonds. 1, 2, 3, and 4. Around this one, we also need 4. So it's 1, 2, 3, 4. Around that one, I've already got 1, 2, 3, 4. Around this one, I need 4, 4, and 1, 2, 3, 4. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so now you just add all your hydrogens because it is a hydrocarbon consisting of only hydrogens and only carbon. And don't learn statically. Don't watch me because then I'm doing the work. You need to work with me. You need to write this down. You need to draw it out with all the hydrogens. I'm not doing it for nothing. And I want you to engrave that neural pattern. And then I want you to count with me as well. Okay, remember you need to number closest to the functional group. And if I start on this side, I have 1, 2, 3, 4. The triple bond lies on the 4th carbon. If I count from this side, it's 1, 2, 3. So it lies on the 3rd carbon. So we're going to start from this side. 1, 2, 3, 4, 5, 6, and 7. And that's what we're interested in, right? Now, as you know, 7 carbons, in terms of its name, we start with the main chain, we count the number of carbons, we see if there's any side chains, and we find the longest chain. In this case, it's very, very simple because there's only one straight chain. There are 7 carbons. As you know, it's meth, eth, prop, bute, pent, hex, hept is 7. So I'm going to put in HEPT. There's at least one triple bond between the carbon atoms, so we don't say ane or ene, we're going to use ine. YNE, and we now need to indicate on which carbon the triple bond lies. So it's going to be here, hept 3-ine. And there we go. That's our first set of examples for the hydrocarbons relating to the alkynes.